Okay, so welcome guys to the third video of binary system, and today we are going to elaborate from denary to binary even more. So let's take a quick example on method 1 that I taught in the last video. Method 1, and it is from denary to binary. It's method 1, also known as LCM method. Okay, so let's say our example is 28. So for converting this into a binary form, we need to take LCM table, and here we need to write 28 in first, and we are going to make some boxes. Like, it's not necessary to make all 8, as I said in the last video, it's just not necessary. Okay, so the very first step, we will start from the base power of 2, because we have to convert it into binary in the form of zeros and ones. So let's start. So the first divisible will be, as we put 2 here, 28 divided by 2, it will become 14. And as you know, the LCM is 0. If we divide it again by 2, the LCM, the 14 divided by 2 is 7. And the LCM becomes 0. Let's do again. If we divide it by 2 again, it is 2 times 3, 6. Like the least possible number, which is just, the maximum possible number, which is just before this number, is 2 times 3, 6, which is just before this number. And so our remainder becomes 1. Our remainder becomes 1. Let's divide it by 2 again. If we divide it by 2 again, 2 ones are 2, which is just before this number. So the remainder comes out 1 again. And the final one, if we divide it by 2, there's actually no divisible that can be done by 2, so we will just write 0, because 0 is possible in the table of 2. If we multiply 2 by 0, it will become 0. So of course we have to write 0 here, because the reason behind is, in LCM method we have to divide this number until and unless we get 0 in final answer. So here the remainder becomes 1, because 2 times 0 is 0, and 1 minus 0 is 1, which is the remainder. And so now the next step will be, we will now interpret it in binary form, like this. These boxes are not necessary to make, but it's just for more elaboration. So as I told in the last video, you have to go from bottom to the top. And as we are writing this number, it will become 11100. Now this empty space, we don't have to fill up this empty space. Actually, since we start from here with in the power of 2's, we don't have to fill up this empty space. If if we have to get the final answer as 8 bits, then we have to place this number 3 positions forward, such that this final 0 comes here, like this. 11100, 11100, and the spaces behind will be filled up. And let me tell you the reason in a second why. It's 2 power 0, it's 2 power 1, it's 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, and that's it. 2 power 0 will become 1, 2 power 1 is 2, 2 power 2 4, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, and then 128. So as our basic rule, we will add all those numbers all together which corresponds to the one or which corresponds to the state of on. Which means that this number, and this number will be added all together to make the final answer 28, so that we can prove that that it is an actual method. So as we add it together, it will become 16 plus 8 plus 4. 16 plus 8 is 24. 24 plus 4 is 28. And this is the answer that we started in the beginning. Okay, so that's the method 1. Let's move to method 2. So before I move to method 2, let me tell you one thing that I said in the last video of proving why an 8-bit number, the maximum number which can be the maximum Denary number which can be represented in an 8-bit binary number is 255. Let me tell you the reason why right now. Let's consider this example. 1, 2, 3, 4, 5, 6, 7, 8. Now before I write these numbers, let me write down the powers first. Powers and the index and all of that stuff. Five, 6, 7. 2 power 0, 1, 2 power 1, 2, 2 power 2, 4, 2 power 3, 8, 16, 32, 64, and then 128. So the maximum number can only be represented if all of these numbers will be added all together, which means that this number, this will be added all together. Only in that case you can say that our number is the maximum possible number that can be represented. So it means that with every number we need to write 1, because the basic rule says that every number that corresponds to 1 will be added. So we need to put 1 with every single number so that every single number can be added to obtain our final largest and biggest number. So we will add all of these as stated. So if we add them all together, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. If we add them all together, you can check it in a calculator. It eventually becomes 255. Okay, so it's been like 9 minutes for this video. So we cannot discuss method 2 in this video because the video will get very long. And that's why we will discuss the second method in the next video. Thank you very much for watching this video, and I will see you in the next one.